So yeah, as Eric mentioned, I'm Pablo Gonzalvez. I'm a director of engineering at Cortical IO based in New York. And I'll try to explain you based on our experience and what we have done on Cortical and the path that we have walked about AI applications and products for the enterprise. And so let me get started just by briefly providing an overview of what we do and why we're focusing on this. So we basically are an NLP company that builds products for enterprises, mainly Fortune 500 or Global 1000 companies. And we started by building our own technology platform. We started building on that, and we continue developing custom projects for some enterprise customers. So there was a lot of early engagements with a wide variety of customers. And then at some point, we did some pivoting of our focus to start focusing on building products based on that technology platform that we built. We had our first product commercial customers in 2017, and there's when basically we started launching our contract intelligence product. And then a few years later, we started launching our message intelligence product. All this comes driven by the market for us. So basically, as we had some engagements and custom projects based on what we saw that we could approach with our technology, we started to build products based on what we saw as patterns of things that repeat over and over. So just let me get started to get more into NLP topics. So if it wants to ahead. So just to provide a bit of context, a real world example and how or why NLP in general is complicated. So you would guess like how many examples would you need to annotate to train a model that covers a vocabulary of 5,000 emails. So we have a product that is message classification that in general works with email. So we have seen this issue, and you will wonder, okay, if I have 5,000 emails for my training data set, that's that's a lot. In this case, we had more. We had what you can see there in the graph, up to 20,000. What you see is that if you see the coverage, you have your training set of 5,000. It doesn't matter really how many you have. You are not going to cover the whole vocabulary that you will see later on in production or with new emails coming in. So you're going to have a problem in general because models will not be able to handle the terms that they've never seen before. So that's a big issue in the NLP industry. And in this case, we were it's a lucky or a great data set. In general, what you see that companies have read is more around these lines, that they have a few hundred annotated samples or 1,000, and that's around the limit of what they can do as having samples for annotations. So we have seen already, like just right at the beginning, like challenge in NLP, or one of the main challenges is the variation of language. So basically you have millions of possible terms, phrases, compound terms, combinations, and the problem is that some of them are extremely frequent, but most of them are extremely rare. And the standard machine learning approach, if you try to do any basic statistical only approach, that's going to be complicated to put that in the models as features, because this is basically the graph. You have, let's say, a small set of common terms that you could explicitly train for, and those will probably appear in your data set. And then you have a long tail it's the long tail of uncommon terms that you're never going to see on your training set. This And that means that there are some limitations. So basically, term-based models have a lot of difficulties to work in production. Then in NLP, there's been a lot of work to mitigate this effect, but in general, it's complicated and difficult to maintain and takes a lot of effort. And like stemming, so basically trying to stem the words to the root, or creating ontologies of words, creating synonym glossaries, so you can, even if you haven't seen it in training, you could have lists of synonyms that would apply also in production, but it's complicated, and again, it's not scalable either. So what that means is that will basically have an impact on your performance in production that you cannot really measure during the training and evaluation phase. So something that we did, and basically either you do this or you apply any other semantic space or similar technology that may exist nowadays. And this is basically how we started. And we started with creating our own way of creating a semantic representation of the language, and basically that helps to basically create that let's say bridge that gap of inferencing between unseen vocabulary and terms that you have in the annotated examples, and basically it provides a higher payload of information for your annotated examples. And we are using this as I mentioned, like we created some technology, then out of the examples we saw in the industry, started to build the products. We were basically using this semantic representation for extraction and classification in general, so for both kind of NLP problems. So just to provide a brief overview of how this works. So we can represent, and that's one of the key items, words and sentences and paragraph in the same 2D or just a binary array vector of features. And all this is unsupervised, and this is basically what you bring as an unsupervised training for your then supervised training to bridge that vocabulary mismatch. And also some just to provide some context, like we are in these binary representations basically capturing all the different meanings of the words, so that also helps to cover like just those maybe more rare usages of certain terms. So this is just how it works. So you have binary representations, and you can have like different words, and basically what is happening to compare the word-to-word representation against the text representation is that basically you can stack them together, you can count the frequencies, you can specify and get a text representation, meaning that you're automatically, let's say, capturing only the positions where the different meanings of the words are overlapping. So that's why this, let's say, helps to later on bridge that vocabulary mismatch, because if you have words that have a similar meaning, they will have a similar representation. So even if it's something that you have not seen in your training corpus, you will be able to then, let's say, relate to it or have a similarity based only on the representation in production. So then this is basically what I was just saying, like you can have terms that you may or may have not seen, but just based on the representation, you can see whether they are similar or not. They don't require to have any word overlap as done deal and sign contract. They don't have any keyword overlap, but the representation is quite similar. So that helps in that direction for the production models. And then if the question is, okay, we built this, let's say, cool technology, and then why did we shift to actually build products? So that's a good question, and we were also wondering about that for some time. And the real answer is that enterprise companies in general, they use new technologies, but in most of the cases they use them to build internal projects and in-house solutions. So all these huge companies, they have innovation departments, they have research labs, they have specialized data scientists, machine learning engineers, all kind of research departments, and they are specialized on building these kind of solutions, and they use all the state-of-the-art technology, and they they will use any tool in hand to build those solutions. So what we saw is that enterprises in general are looking for products that are solving real-world problems, and there are many reasons to do that. Even though that they could actually probably build it on their own, in general, if a product is solving a problem for the enterprises, that's much lower risk for them, because they can quickly test if that product actually solves their problem, and whether or not solving that problem makes a difference to them. That's a much shorter time to production. So if a third-party company can offer them a product and they can just go and install it, that's going to be much faster for them than if they have to build it. And that gives them also the ability to calculate a return on investment. So enterprises, well, all the companies are about making money, but enterprises have a clear focus on that, and being able to calculate a return on investment on if they're building a product or if they're buying it, it's much easier when they are buying it, because there's a price attached to that, and they know that, and they can test how much is gonna save them, basically. So yeah, after this like brief intro on technologies and why it could be relevant or not to build a product if you're targeting enterprises. So let's go to some real world examples that we have seen. So one is about contract review and analysis. So this is something that we have seen, and it's very related to NLP. Like you have a lot of companies that they have many subject matter experts that are doing boring and repetitive, and in general, because of that, error-prone processes. And they are basically going through documents, contracts, legal documents, manually to extract information. And they do that on their day-to-day basis. Some of them do it as a full-time job. So it's a tough position, and they're just reading documents, extracting information, and placing it somewhere for that data later on to be analyzed or used for any purpose. The third problem associated to that is, I would say, that lack of visibility. You have 50 individual subject matter experts doing their extractions individually. You don't have any aggregate on that data that would help you as a company to have any insights on the data. And this just to provide some specific okay, what's the specific of this? So one specific problem in this case was with an insurance company, and they basically have many subject matter experts that are going through prior carrier contracts, and that means, like, just to provide a bit of context on how this works. When an insurance company, excuse me, that is working insurance for other businesses wants to acquire a new business, basically they get a request from a broker and says, hey, you are insurance company A, I have this client and they have currently insurance company B. and I want you to make an offer. These are the 5 documents, 5 contracts that they currently have. Read it and make an offer that it's better or have better coverage or is cheaper. So when that happens, then one of those SMEs has to go through those 5 documents. Each of them might range from 20 to 100 pages. So that's going to take some significant amount of time, and and they have to extract the information. So what we did there was just to get their requirements. They need accuracy with extracting documents. They need to allow the subject matter experts to define what they need to extract. They need to be able to build their own models, and they need to be able to have the predictions fine-tuned and basically quickly aggregate everything that goes there. So again, the main goal was to speed up and help them through that process. And then the other real world example that's basically a message classification with nowadays world, like just not emails, but customer service. And still, email is the most used channel for customer service, but there are many others at this point. The number of messages for companies is growing dramatically. And what this translates is that they have poor customer service because they cannot dedicate more resources to that, and that has a high cost, and in some cases even some risk for compliance. Again, briefly a use case about this. So a company receiving 100,000 emails per day, and this is not across all their employees. This is in a specific inbox. You can imagine like an inbox as support at Cortical or something like that. Their inbox for this incoming emails, and they were receiving 100,000 emails per day. So handling that, it's tricky. They have many people handling that, but still, like, they know that there are many ways to automate that, and that's part of what we try to do with this, basically classifying those emails automatically and providing them with the flexibility to fine-tune those classifiers and how to route and how to basically manage and handle that volume. So once that we have seen some real use cases, let's get into what they see as requirements in general, what we have identified in many cases as common requirements. Okay, sorry, this went backwards. So one of the main requirements that we have identified is flexibility. So if you build a product for enterprises, it needs to give them flexibility. Also, for your own sake, it needs to have flexibility, because even the same use cases in different companies will have different requirements, as integration with different data repositories, contract lifecycle management, contract repositories. They need to customize their classification and extraction models. They need to be able to train that. They need to have control of that, model creation, model management, training and evaluation, fine-tuning. And the one that we have seen the most, or one of the key items as well, is that it needs to be built for the subject matter experts. The end users are the ones in the driving seat, and they don't necessarily know anything about NLP, machine learning, or data scientists. They are just experts on their industry and on their topics, and those are the ones using it. They need to be able to use it. So what we saw there is that if you build a product for the subject matter experts, you need to allow them to actually build the models and understand what they are doing. So they start by defining what they want to extract. You can upload some samples, you can annotate them there, and you can actually train the models all within the same application. That basically gives them that whole feedback loop. They can see how it works, and they can keep fine-tuning it. They can, of course, check at the evaluation, but what they understand the most is when they see it in real life with new documents. And the other step is in production. Similar process. You upload documents, and the SMEs, if they have to at any point go and validate anything for those extractions or classifications, they can always provide feedback, and that will keep improving the model. So that gives them basically the control, and basically sends over the control of all this to the company instead of to yourself. One step also that it's important is to give them all this control. They may not be data science or machine learning experts, but they need to understand what they are doing so they can do the training within the user interface. You have to show and explain the evaluation. So everyone of us might be familiar with, for example, like confusion matrix, but subject matter expert will not. So it's good to explain them, like, look, just with a mouse over, like this means that there are some samples of this that were misclassified as this other, so they understand what they are saying, and they can quickly get a grasp on what that means, or they can even just test within like real time what's happening there. And of course, we're not forgetting about data scientists or anyone that the company may have. Like, you want to provide the REST API access for additional flexibility or any additional features that you may have for training and evaluation in case they want to actually play with that. So some other requirements out of flexibility and building it for the SMEs is basically application security and data security. Application security, many will say it's unrelated to machine learning and NLP, and it is, but this is strictly required. I think nowadays, if you want to work for any enterprise, application security, it's a must, and it's not going to go anywhere if you don't have it. You need to have certain things. This is just basic things. If you don't say that you have this, basically you are not even considered. You need to have authentication, authorization. You need to have encryption, like all the way through. You need to offer high availability, disaster recovery, and of course, application and system monitoring. So all that, it's basically a must. May not have anything to do with machine learning or NLP, but you need to have it in your application. And then for data security, very critical, because in most of the cases, you don't even have access to the data. So in many cases, we work with customers and they have the data on their end. We cannot see the data. You need to train the SMEs to actually use the application for that reason, and they need to be able to train the models on their end. And that means that needs to be able to deploy this application on premise, and you need to have a robust application to ensure that this will actually work when it's on premise, and it's not going to be a problem when you have unseen data sets of any kind. So just to come up with a few conclusions after all this. Sorry. In most of the cases, the challenges we have seen is that you start with innovation departments, and you somehow need to manage to engage a line of business to make sure that there is some budget ensured. Like innovation departments in general, like trying and testing different products and technologies, but you need to ensure that there's going to be a budget behind that. Then there is the build versus buy dilemma. Those innovation or research departments will always be able to build it in-house. So they are in general the gatekeepers. They're the ones that are going to assess whether or not your product will actually work for them, and they have to basically give their blessing before you actually enter the company. That's that's what it is. And then usually that leads to an initial phase to prove it with line of business, a proof of concept, where they will actually have that period of time to train real models with their data and test it with that real world data. So if I can basically provide some takeaways out of all this that I've been saying. So here we have a build versus buy dilemma. I think that's always going to be there for the enterprises. They are constantly considering whether to build something or to buy something, and they are scouting for new products and new technologies. The other is that your applications, if you're building products, they must solve real world problems. So you have to try to find what's called a product market fit. It doesn't matter how cool your application is or how much you like it. If it doesn't solve a real world problem, nobody's going to buy it. And then flexibility, as I mentioned, like that it's a must to accommodate enterprise requirements. And of course, security, critical to ensure that privacy and integrity of their data, that it's one of their most valuable assets.